Good morning, all of you. Today we will be continuing with properties of rational numbers, and we were discussing about closure property and property for whole numbers and integers. We have already discussed in the last videos, and today we will be discussing about closure property for rational numbers. Okay, and we will start with addition. So let's see addition for rational number. Okay, I'm taking one example. Okay, suppose this is our question 3 by 4 plus minus 5 by 7. So we are going to add two rational numbers. Okay, so what will be the answer? How do you add two rational numbers? The actual process is taking LCM and all, but for easy adding, what you can do? You can just cross multiply them. That is 3 into 7. Okay, plus minus 5 into 4. Divided by what is in the denominator 4 into 7. So 4 into 7. Okay. Now what is 3 into 7? 21. 21 plus what is minus 5 into 4? Minus 5 into 4 is minus 20. Okay. Divided by what is 4 into 7? It's 28. Okay. Now what is 21 plus minus 20? You know that the answer is plus 1. Okay, you have to subtract them and put the sign of bigger number. So plus 1 by 28. So our answer will be 1 by 28. Okay, so here we have taken two rational numbers 3 by 4 and minus 5 by 7, and we have added them, and the answer is again a rational number. So we can say that rational numbers are closed under addition. Okay, you can take more examples. For example, I am taking minus 4 by 5 plus minus 1 by 2. Okay, now how will you add them? Just cross multiply. That is minus 4 into 2 plus minus 1 into 5. Okay, divided by in the denominator 5 into 2. Okay, now what is minus 4 into 2? Minus 4 into 2 is minus 8 plus what is minus 1 into 5? It's minus 5. Okay, divided by what is 5 into 2? That is 10. Now what is minus 8 plus minus 5? Answer is minus 13 divided by 10. So our answer is minus 13 by 10. So here also you have taken two rational numbers and added them, and the answer is again a rational number. So we can say rational numbers are closed under addition. Or you can say for any two rational numbers a and b, a plus b is also a rational number. That is the correct definition for closure property. Or you can say rational numbers are closed under addition. Okay, so that is the conclusion that we are getting. Now let's see what is the case of subtraction. What is the case for subtraction? Okay, now let's see the case for subtraction, and I am taking the rational numbers as minus 3 by 2 and 5 by 7, and I am going to subtract them. Okay, so how will you subtract them? You know that you have to write the first number as it is, and you have to put the positive sign, and then you have to put the additive inverse of 5 by 7, which is minus 5 by 7. Okay, in this way you can do the subtraction for rational numbers. Now you know that you can just cross multiply them. Actually you are taking the LCM and multiplying and all, but for easy doing you can do it in this way. Okay, you have to just cross multiply them. That is minus 3 into 7, then plus what is remaining 2 into minus 5. Okay, divided by what is in the denominator 2 into 7. Okay, so what is minus 3 into 7? It's minus 21 plus what is 2 into minus 5? It's minus 10 okay, divided by 2 into 7 is 14, okay. Minus 21 plus minus 10, you know that the answer will be minus 31, is it? You have to just add them and put the negative sign, divided by 14. So our answer will be minus 31 by 14, okay, easy. So here you have taken two rational numbers, that is minus 3 by 2 and 5 by 7, and you have subtracted them, and the answer is again a rational number. That means what? Rational numbers are closed under subtraction. Okay, you can take more examples. For example, I am taking 4 by 5 minus 5 by 8. Okay, and I am going to subtract them. So what is 4 by 5? You can simply write it in this way, plus minus 5 by 8. Okay, so our answer will be, what is 4 into 8? 4 into 8 is 32, plus what is 5 into minus 5? It will be minus 25, divided by what is 5 into 8 in the denominator. 5 into 8 is 40. Okay, so what will be the answer? 32 and minus 25. That means you have to subtract them, and then you will get the answer as 7 divided by 40. This is the answer. So here also you can see that you have taken two rational numbers and subtracted them, and the answer is again a rational number. Okay. So from this you can see that rational numbers are closed under subtraction. Okay, rational numbers are closed under subtraction. Or you can say, for any two rational numbers a and b, a minus b is also a rational number. Okay, for any two rational numbers a and b, a minus b is also a rational number. Okay, so this is the conclusion. Okay, or you can say rational numbers are closed under subtraction. Okay, you can take more examples and see if you want. Now let's see what is the case for multiplication. Okay. Now for multiplication, I am taking the rational number as minus 3 by 5, and I am going to multiply it with another rational number 4 by 5. Okay. And here you can see that when you multiply minus 3 into 4, what will be the answer? It's minus 12. Now what is 5 into 5? It's 25. Okay. So minus 12 by 25. So here you have taken two rational numbers and multiplied them, and the answer is again a rational number. That means you can say rational numbers are closed under multiplication. Let's take some other examples. For example, I am taking 4 by 5 into 3 by 5. Okay. Now what will be the answer? 4 into 3 is 12. 5 into 5 is 25. So our answer will be 12 by 25. That means what? Here you have taken two rational numbers and multiplied them, and the answer is again a rational number. So you can say that rational numbers are closed under multiplication. Now minus 4 by 5, and I am going to multiply it with minus 6 by 11. Okay. Now what will be the answer? You know that minus 4 into minus 6 is 24. Okay. And what is 5 into 11? It's 55. Okay. So our answer is 24 by 55. Okay. Here also you have taken two rational numbers and multiplied them, and the answer is again a rational number. That means you can say what? Rational numbers are closed under subtraction. Okay, rational numbers, sorry, not subtraction, multiplication. Rational, that means you are taking two rational numbers and multiplying them, and the answer is again a rational number. That means rational numbers are closed under multiplication. Or simply you can say, if for any two rational numbers a and b, a into b is also a rational number. Okay, rational number, or you can say rational numbers are closed under multiplication. Okay. Now let's see what is the case for division. Okay. Here again I am taking two rational numbers. Suppose I am taking minus 5 by 3 and going to divide it with 2 by 5. Okay, I am going to divide minus 5 by 3 with 2 by 5. Okay, so how will you perform the division? You know that you have to write the first number as it is, and then you can divide it with the reciprocal of, you can, instead of this division sign, you can put this multiplication sign, and then you can put the reciprocal of 2 by 5. What is that? 5 by 2. Okay, so what will be the answer? Minus 5 into 5 is minus 25, divided by, what is 3 into 2? It's 6. So answer will be minus 25 by 6. So here also you have taken two rational numbers, minus 5 by 3 and 2 by 5, and divided them, and the answer is again a rational number. So in this case you can say rational numbers are closed under division. Now let's take any other example. 3 by 7 divided by 6 by 5. Okay, so here you can see that 3 by 7, instead of division you can put into sign. Then what is reciprocal of 6 by 5? It's 5 by 6. So what will be the answer? 3 into 5 is 15 and 7 into 6 is 42. So answer is 15 by 42. So here also you have taken two rational numbers, 3 by 7 and 6 by 5, and divided them, and the answer is again a rational number, which is 15 by 42. Okay, so here also you can say that rational numbers are closed. But let's see, if I am taking a rational number, say 3 by 7, and I am going to divide it with 0. Okay, so can you divide any rational number with 0? Any number, you can take simply 7 divided by 0, or any number. In all these cases you can see that all such numbers are not defined, or you cannot perform these type of division, or you cannot perform division with 0. Okay, any number divided by 0 is not defined. Okay, that means what? That means rational numbers are not closed under division. Okay, any number cannot be divided with 0, so you can say that rational numbers are not closed under division. Okay, or you can say that a divided by 0 is not defined for any rational number a. Okay, you can say for any rational number a divided by 0 is not defined, or you can say that rational numbers are not closed under division. Rational numbers are not closed under division. Okay, this is the conclusion about rational number. Okay, so in the first three cases you have seen that rational numbers were closed under addition, subtraction and multiplication. That means if you are taking any two rational numbers and adding them, subtracting them or multiplying them, then you will get the answer as a rational number itself. That is why you can say rational numbers are closed under addition, subtraction and multiplication. But what is the case if we are dividing two rational numbers? Then the answer will not be a rational number in some cases. So you can say that rational numbers are not closed under division. Okay, let's see the conclusions. Rational numbers are closed under addition, subtraction and multiplication, but rational numbers are not closed under division. Okay.